So, let's go.
Number 10. Earth already broke its own rules. In 2009, a team of scientists, led by Johan Rockström at the Stockholm Resilience Center, mapped out 9 systems that have to stay balanced for this planet to keep behaving the way it always has. They called them the planetary boundaries. Think of them as load limits, the way a bridge has a maximum weight before the engineers stop guaranteeing it won't collapse. As of the most recent assessment, 7 of those 9 boundaries have already been crossed: climate, biodiversity loss, freshwater use, the nitrogen and phosphorus cycles, land conversion, ocean acidification, synthetic pollution. Right now, atmospheric carbon dioxide sits above 424 parts per million, pushing a level of heat-trapping force nearly double the threshold scientists consider safe. Here's where it gets uncomfortable. This isn't a future risk, it's a current condition. The planet's natural ability to absorb our waste, the way your lungs filter the air you breathe without you ever thinking about it, is starting to fail in the same quiet way a smoker's lungs fail. You don't notice the damage day to day. You notice it when the system stops keeping up. What should worry you about? This is how invisible the threshold crossings actually are. Nobody felt the moment Earth crossed 7 boundaries instead of 6. There was no alarm, no headline that mattered enough to change behavior. Amazon didn't announce its die-off. The permafrost didn't ask permission before it started thawing. These systems move on their own schedule, indifferent to whether we're paying attention. And underneath that is something worse. Several of these boundaries are connected to feedback loops, meaning once they tip, they don't just degrade slowly, they accelerate the next one. Melting ice sheets release stored carbon. Lost forests stop absorbing it. Each failure makes the next failure easier. Scientists have a name for the end state of that chain: a hothouse Earth, a planet that has shifted into a hotter, less habitable equilibrium with no clean way back. We built our entire civilization, assuming the ground beneath it was stable. It was never actually stable. It was just slow. All right, number 9. There may not be room for all of us. 2 billion people. That was the entire human population in 1930. 8 billion people. That's where we are right now. 10.4 billion. That's the population ceiling demographers project by the end of this century, the rough point where global numbers are expected to plateau. Picture an apartment built comfortably for 4 people that now has 10 living inside it. Nothing about the apartment changed. Everything about what it can support did. This expansion has been called the Great Acceleration, a period where agriculture, industry, and resource extraction scaled up faster than at any point in human history to feed and house all those extra people. One side effect: the current rate of species extinction now runs more than 100 times higher than what scientists consider the safe background rate, measured in extinctions per million species per year. For a moment, just sit with that number: 100 times. Not because every viewer needs to feel guilty about it, but because it's genuinely strange that a single species accidentally became a geological force capable of reshaping extinction rates the way an asteroid or an ice age once did. There's something almost vertiginous about that. In a species that still argues over parking spaces, the detail that makes this hard to shake is that none of this requires a villain. No single decision caused it. It's the accumulated weight of 8 billion ordinary lives, each one entirely reasonable on its own, adding up to something the planet was never built to hold indefinitely. If growth continues on Earth alone, something eventually has to give. Living standards, population size, or the ecosystems themselves. There is no version of infinite growth on a finite surface that ends quietly. Number 8. We are one bad day from losing everything. 66 million years ago, an object, roughly 10 kilometers across, struck what is now the Yucatan Peninsula and ended the age of dinosaurs in geological time, which is to say, almost instantly. That event didn't require malice. It didn't require a decision by anyone. It required a single roll of cosmic dice that happened to land on a number that erased most life on Earth. Here's the uncomfortable math behind the 8,700 and something asteroids of significant size and counting, all routinely cataloged by astronomers tracking near-Earth objects. Most pose effectively no risk. The orbits are known. The trajectories are calculated decades in advance, and the odds of a civilization-ending impact in any given century are vanishingly small. Researchers studying existential risk consistently find that natural threats like asteroids, supervolcanoes, and nearby supernovae make up a tiny fraction of the danger humanity actually faces. This is where it stops being interesting and starts being uncomfortable. The reason natural risks rank low isn't because Earth is safe. It's because we got lucky for a very long time. The way a gambler can sit at a table for years without losing, right up until the night they don't. Civilizations are vulnerable to this, regardless of where the threat originates, whether it falls from the sky or is built in a lab. Any single sufficiently severe event on one world ends everything for a species that only exists on one world. Which means, if you follow it all the way through, every species in history that has ever existed on exactly one planet has had exactly one chance to be wrong. We have had that one chance for the entirety of our existence, and so far, the dice haven't landed badly. That isn't a strategy. That's a streak. Number 7. The button has never stopped being a possibility. What actually stops a handful of countries holding nuclear arsenals from making one catastrophic decision that ends civilization as we know it? The honest answer is fragile. Overlapping systems of deterrence, treaties, and human judgment under extraordinary pressure, none of which are guaranteed to hold forever. Researchers studying existential risk place the danger of a large-scale, possibly escalating nuclear conflict among the more serious threats facing humanity this century, not because anyone wants this outcome, but because the infrastructure capable of producing it has existed continuously. Since 1945, the year the first atomic weapon was detonated. Since that year, human technological capability has consistently outpaced the wisdom and institutional restraint needed to safely contain it. Think of it like a smoke detector that has been sitting on the wall for 80 years, occasionally beeping, occasionally being silenced, but never once fully disabled and never once fully trusted either. You don't think about it most days. It's just there, doing its job in the background, until the one day the background becomes the foreground. What nobody quite says out loud is that the danger isn't really about any specific government or specific leader. It's structural. As long as planetary-scale destructive capability exists without a planetary-scale governance structure to match it, the system carries an irreducible amount of risk that no single safeguard fully eliminates. You cannot build a perfect lock for a door that several different parties all hold separate keys to. And the truly disturbing implication is this: a single point of catastrophic failure doesn't need to happen often to be devastating. It needs to happen once. Civilizations that survive that kind of risk for centuries aren't proving the risk is small. They're proving they haven't rolled the unlucky number yet. Number 6, something we could build by accident. When a researcher working in advanced biotechnology today wants to understand how a pathogen might evolve, they're working with tools that, in the wrong hands, or simply in the wrong moment of carelessness, theoretically allow for engineering an organism that is both highly transmissible and highly lethal. The kind of combination that traditional public health defenses were never designed to catch in time. This is not the same threat as a naturally occurring pandemic. A naturally evolved virus is shaped by the same evolutionary pressure that limits most pathogens, the pressure to keep a host alive long enough to spread. An engineered one isn't constrained by anything except the intentions or the mistakes of the people who made it. Here's the part that should genuinely concern you. The primary global institution tasked with preventing the proliferation of biological weapons, the Biological Weapons Convention, currently operates with a staff of around 4 people and a budget smaller than a single fast food restaurant generates in sales each year. Picture trying to guard the door to the most dangerous laboratory technology in human history with the staffing of a corner shop. It's almost beautiful, in a strange way, how fast biotechnology has advanced. Tools that once required entire national laboratories are increasingly available to small teams and even individuals. The same techniques that could one day cure inherited diseases or engineer crops to survive a warming planet are functionally identical at the molecular level to the techniques that could engineer something far worse. What makes this particularly unsettling is that the danger isn't really about evil intent. It's about a single irreversible mistake, a voicemail you can't unsend, propagating through a global population with no immunity and no warning. Biological risk, unlike a missile, doesn't announce itself with a launch. It announces itself with a cough that's already too late to stop. Number 5. Our star is quietly turning against us. There is a number buried in solar physics that almost nobody outside the field has ever heard, and it might be the single most important number for the long-term future of every living thing on Earth. The sun's luminosity has increased by roughly 33% since the solar system formed about 4.57 billion years ago, and it continues growing steadily hotter by roughly 8% every billion years as hydrogen fusion gradually changes the density and temperature of its core. For a moment, picture the early Earth nearly 4 billion years ago, sitting under a sun that was only about 80% as bright as the one we see today, kept from freezing over entirely by a thick blanket of freighter greenhouse gases. That world looked nothing like ours, and yet it was just as real, just as inhabited by early life finding a way to survive under a dimmer star. There's something almost calming about that. The idea that Earth has already lived through one completely different version of itself. What makes this particularly disturbing is what happens next, on a timescale that sounds safely abstract until you actually sit with it. In roughly 600 million years, rising solar radiation will accelerate the weathering of rock in a way that strips carbon dioxide out of the atmosphere so completely that plants relying on the most common form of photosynthesis simply can't function anymore, collapsing the base of the food chain. Within about 1 billion years, the sun's brightness will be 10% higher than it is now, enough to trigger a runaway evaporation of Earth's oceans into the upper atmosphere, like water, slowly rising over a low-lying coastline until the Carrefour-NA. Tide simply never goes back out. The deeper problem is this: none of that requires a mistake. It requires nothing from us at all. The sun does not need humanity's cooperation to make this planet eventually uninhabitable. It was always going to happen. We just happened to be alive early enough to watch the early stages of the clock running. Number 4. The magnetic shield that won't last forever. Earth carries an invisible compass, a magnetic field generated deep in its molten core. And that compass is the only reason the atmosphere we breathe hasn't already been stripped away by the constant pressure of the solar wind. Without it, the same fate that already happened to Mars billions of years ago would eventually happen here. Following the same solar heating timeline that's already reshaping the atmosphere, scientists project that within roughly 2 to 3 billion years, the loss of Earth's oceans will halt plate tectonics, since the mechanical lubrication those oceans provide is part of Baytet. What keeps tectonic plates moving at all? With plate tectonics gone, the planetary carbon cycle effectively shuts down, and not long after, the magnetic dynamo inside Earth's core is projected to cease entirely, removing the shield that has protected the atmosphere since the planet formed. Once that shield is gone, the solar wind does what it has always wanted to do. It scours the remaining atmosphere away, particle by particle. the way wind slowly wears down a mountain over millions of years until there's nothing left to erode. By around 4 billion years from now, Earth is projected to resemble present-day Venus, a surface hot enough to melt rock under skies that no longer have a magnetic compass guiding anything away from disaster. The truly disturbing implication is this. The thing currently keeping you alive right now, this second, is a magnetic field you've never seen, generated by churning metal thousands of kilometers beneath your feet, and it has an expiration date that has nothing to do with anything happening on the surface. We're protected by a process we did not build, cannot repair, and cannot replace. Number 3. The day our sun eats its own planet. There is a photograph, in a sense, sitting at the end of every star's life. And the sun's version of that photograph is currently scheduled. In about 7.5 billion years, the sun will exhaust the hydrogen fuel in its core and begin expanding into what astronomers call a red giant phase, swelling outward until its outer layers very likely engulf the orbit Earth currently occupies before the sun eventually sheds those outer layers entirely and collapses into a white dwarf, a small, dense ember of what it used to be. Here's the plain version. The star that currently makes every form of life on this planet possible is also, eventually, the exact mechanism that destroys the planet itself, not metaphorically, physically. The same fusion reactions providing warmth and light today are the ones that, billions of years from now, will expand outward and consume the very world they once sustained. A photograph left in direct sunlight doesn't vanish all at once. It fades slowly, the colors shifting and weakening for years before the image is finally gone for good. Earth's ending follows roughly the same arc. Long before the sun physically reaches Earth's orbit, the planet will already be unrecognizable, a scorched, lifeless husk shaped by billions of years of escalating heat that started long before the final act. And here's the part that's easy to miss in all the cosmic scale. This isn't a risk. It isn't a probability we're trying to calculate or mitigate. It's a certainty etched into the basic physics of how stars age. Every other reason on this list describes something that might happen. This is the one outcome that absolutely will, given enough time, whether humanity does anything about it or not. Number 2. The cost of every second we wait. In 2003, philosopher Nick Bostrom, then at Oxford, published a calculation with a deceptively dry name, astronomical waste. The idea underneath that name is anything but dry. He argued that every single second humanity delays, expanding into space, represents resources permanently lost, because the universe is continually expanding and unused energy is continually degrading into forms nothing can ever use again, slipping past black holes and cooling. Stars like interest you were too late to collect. Here's the scale of what's actually at stake. A single star, using conservative estimates of future technology, could theoretically support around 10 billion biological humans. The Virgo supercluster alone contains an estimated 10,000 billion stars. Multiply those numbers and you get a population so large it stops feeling like a number and starts feeling like a category error, a quantity the human mind isn't really built to hold the way it holds the population of a city or even a country. For a moment, it's worth just sitting with. How strange that is. Trillions upon trillions of potential lives, flourishing lives, never coming into existence simply because of how slowly one species in one solar system chose to move. There's something almost beautiful about the scale of what's possible before the weight of what's being lost catches up with you, which leads to a conclusion most people aren't ready for. If you treat every unrealized life as having real moral value, then every year of delay in becoming a spacefaring civilization isn't neutral. It's closer to a savings account losing more value the longer it sits untouched, except the currency being lost is potential conscious experience itself, gone before it ever had the chance to exist. Number 1. We might build the thing that replaces us. In 2020, philosopher Toby Ord, working at Oxford's Future of Humanity Institute, published an estimate that the total risk of an existential catastrophe occurring within the next 100 years sits at roughly 1 in 6. Read that again slowly. Not 1 in 6,000. 1 in 6. Out of every 6 versions of the next century that could unfold, current estimates suggest one of them ends with humanity's potential for a future permanently destroyed. The single largest contributor to that number isn't a virus, isn't a bomb, isn't a burning planet. It's artificial general intelligence. We fail to align with human values, carrying an estimated 1 in 10 chance of causing exactly that kind of catastrophe on its own. Here's the plain version of why that ranks above everything else on this list. A nuclear war, however horrific, would very likely leave survivors, and survivors can eventually rebuild. A misaligned superintelligence doesn't necessarily need violence to permanently end humanity's trajectory. It only needs to systematically outthink every safeguard we put in front of it, the way a chess player doesn't need to threaten you, only needs to be better at the game than you are, every single time, forever. There's a philosopher named Derek Parfit who once asked people to compare 2 scenarios: a catastrophe that kills 99% of the world's population, and one that kills everyone. Most people's first instinct is that the second scenario is only slightly worse than the first. Parfit argued the opposite, and argued it convincingly. The difference between 99% and 100% isn't 1 extra percentage point of loss. It's the difference between humanity continuing to exist, rebuilding, learning, creating everything that would have come after, and humanity's entire future. Every book never written, every child never born, every idea never had, being erased permanently and all at once. This is the point where the idea turns on you. We are right now building the single technology most likely to determine which of those 2 futures we get, and we are building it faster than we are building any meaningful way to control it. Every reason on this list before this one describes a threat that could end human life on one planet. This is the only one that could end the part of us capable of starting over anywhere at all. If you want to see more videos like this, click the video on screen now and make sure to subscribe.